Hello guys, so in this video what I want to do, I want to compute improper integrals. So first you need to remember that by definition improper integral means that I just want to take the limit of a definite integral between 3 and a, where a is just some constant, and I have my original function 4 over square root of x dx. So what is the meaning of improper integral? You can see in our limit we have a definite integral between 3 and a. And you should remember that the geometric meaning of a definite integral is the area under the curve. So if I'm going to sketch this curve 4 over square root of x, then I'm going to sketch two lines 3 and a, I'm going to obtain this area. So, and then the idea is if I want to find the proper integrals, I just want to take my right bound, which is a in this case, and send to infinity. And if you can see on the picture that when I'm going to send a to infinity, I'm going to obtain the area on the right of my line x is equal to a. So in that case, we have in this case, we have two options. We either going to obtain that our integral is going to be convergent. It means that the area is going to be finite, or in other words, we're going to get as answer a finite number, or our area can be divergent. So in other words, our final answer is going to be like positive infinity. So let's try to figure out what we're actually going to get for this problem. So in other words, let's do a direct computation. So let's take this integral, and what do we need to do? We just need first compute it, and then as a second step I need to send my a to infinity to figure out if I have case 1 or case 2. For that you can see if I'm going to do a simple algebra manipulation, that square root of x is equal to x to the power 1/2. And then I can move the power to the top, so I'll put negative sign. And after applying the power rule, I will get that my answer is going to be 8 times square root of a minus square root of 3. And this is like step 1. And right now as a step 2, I need to take my a and send it to infinity. But if a goes to infinity, then square root of a goes to infinity, in other words, like to positive infinity. But that means that my answer is going to be an infinity, because if you have infinity minus some finite number and times some finite number, you still have an infinity. So you can think about infinity as a really, really big number. In other words, we got that for this particular integral, we're going to have that our integral divergent. As our next problem, let's try to do 8.4.5. So we have the improper integral between negative infinity and negative 2 of 2 over x cubed. So that's why, since I have a negative infinity on the bottom, I'm going to set up this integral as a limit when a goes to negative infinity of the integral of a between a and negative 2. And then we're going to use the same trick. We're going to move x cubed to the front, so I'm going to put negative sign in front of 3. And then if I'm going to use a power rule, I will obtain 2 times x to the power of negative 2 over negative 2, and 2 and negative 2 will get cancelled, will give us negative 1. And then I'm going to move my x squared back to the bottom, and I will have my limits between a and negative 2. So I'm going to obtain minus 1 over negative 2 squared minus 1 over a squared. Or in other words, if I'm going to distribute the minus, I will have minus 1 over 4 plus 1 over a squared. And here, if I'm going to send a to infinity, then you can see that 1 over a squared is going to go to 0. As when number is getting bigger, bigger, and bigger, then 1 over that number is going to get smaller, smaller, smaller. So just think that if you're going to have 1 over million, it's going to be like really small number. But if you're going to have 1 over like a billion, it's going to be even smaller. And then if number at the bottom is going to get bigger and bigger, then overall fraction is going to get smaller and smaller. So that's why the final answer is going to be negative 1 over 4. Finally, let's just consider like problem 7, 9, and 11 and think about them as a general case. For that, you should recognize that we're going to have x inside our function, and our bounds are going to be either between negative infinity and some negative number, or between 1 and positive infinity. And observe that all integrals are going to be of the form of 1 over xn. And we're going to have only two cases. One case when we're going to deal with positive infinity, another case when we're going to deal with negative infinity. So let's consider the first case when we're going to deal with positive infinity and try to analyze it. To compute that integral, again, I need to compute the finite integral between 1 and a. So let's take n doesn't equal to 1, and then I'm going to rewrite my function. And if I'm going to integrate, I'm going to obtain x to the power of negative 1 plus 1 over negative 1 plus 1. And that's why I don't want n to be equal to 1, because if n is equal to 1, then negative n plus 1 is going to be equal to 0. But when it equals to 0, and since it's in the bottom part, I cannot divide by 0. And don't forget our bounds between 1 and a. So since n doesn't equal to 1, we're going to have two options. N is strictly bigger than 1 and n is strictly less than 1. If I'm going to take n is strictly bigger than 1, then you can see that n is strictly less than negative 1. And if I'm going to add 1 to both sides, I will obtain that negative n plus 1 is strictly less than 0. But then it means that that power is strictly less than 0. Or in other words, if you have that power of your number is strictly less than 0, then you can take that number and move to the bottom. So that's why what I'm going to do, I'm going to just move that x to the bottom, and I'm going to change the sign of my power, so I'm going to have x to the power of 1 minus n. And I have the same bounds between 1 and a, so here I'm going to factor my constant minus n plus 1, and I'm going to obtain 1 over a to the power of 1 minus n minus 1 over 1. And I have that if I'm going to take my a to positive infinity, then you can see that 1 over a to the power of 1 minus n is going to go to 0, because again, if n is getting bigger, bigger and bigger, and since 1 minus n is strictly bigger than 0, then that number is going to get smaller and smaller and smaller. So my final answer is going to be negative 1 over 1 minus n. So my integral converges. So it converges for all n strictly bigger than 1. And also, I want you to check that if n is going to be strictly less than 1, then my integral is going to diverge. And another thing that I want you to check, what is going to happen when n is equal to 1. So please take a look. And again, my integral is divergent when n is strictly less than 1. And so let's just try analyze and see, to answer a simple question. Do our integrals converge or diverge? So in this case, let's take the first integral, and what do I have my n? My n is going to be strictly bigger than 1, that's why that integral converges. For my second integral, I'm going to obtain n is equal to 2. So again, 2 is strictly bigger than 1, my integral converges. And for the last one, I will need to move x to the bottom, so I'll have 17 over 7. But if you see that 17 over 7 is obviously going to be strictly bigger than 1, then again, that integral is going to converge. So the general idea, if you're going to see this like a proper integral, and you're going to write as 1 over x to some power, and if that power is going to be strictly less than 1, then you can for sure say that that integral is going to diverge.